नमस्ते फ्रेंड्स. या व्हिडिओमध्ये आपण काय बघणार आहोत? 5 मार्क्स क्वेश्चन बघणार आहोत. दॅट क्वेश्चन इज डिपेंडिंग अपॉन प्रॉपर्टीज ऑफ लाप्लास ट्रान्सफॉर्म. आणि ती प्रॉपर्टी जी आहे ती मी तुम्हाला आधी लिहून देतो, एक्सप्लेन करतो आणि मग ती प्रॉपर्टी आपण एक्झाम्पल सॉल्व करण्यासाठी यूज करूया. समटाइम्स प्रॉपर्टीज ऑल्सो आस्क फॉर 5 मार्क्स ॲज अ थिअरी पार्ट. ओके, सो फर्स्ट ऑफ ऑल वी सी थिअरी अँड देन वी फॉलो by problems. This property is known as Laplace effect of division by t, because 1 by t you can see f of t is divided by t, that means 1 by t is a factor, and this property is known as Laplace of division by t or effect of division by t. You are given function f of t already, and then if it is divided by t, then this comes. Here we assume that truth, assume or say given Laplace of f of t is equal to 5ps. This is always given. Assume. Every time it is assumed. Now, how to find out Laplace of 1 by t into f of t, and how to prove that 1 by t helps for integration. Here we can observe that this is function of t on left, and here we can observe that this is function of s on right. Okay, property may be asked to prove for 5 marks. There are half dozen properties, and out of these 6 properties, this property is known as effect of division by t. So let us start with RHS, not LHS. This is what is the speciality. What is the speciality of this property? This property is simple, easy to prove from right to left. It is not usual. Okay. So we start with right hand side. Integration from s to infinity s into s, which is same as integration from s to infinity. This s is nothing but Laplace transform of f of t. Just now we have written ds. So which is again can be written as s to infinity. And now you can tell me what is Laplace transform of f of t. What is the formula for Laplace transform? Can you? Integration from 0 to infinity. So let us practice with me. Then what is there? E. What is the power of e? Yes. And one more thing, this one, isn't it? This is what is Laplace transform. ds should be there. Okay, don't forget to write ds. So again, see, RHS is taken, s is nothing but definition is used. You can see double integration, which is same as. Now there are two integrations. This integration is with respect to s, and this integration is with respect to t. So we change the order of integration, 0 to infinity, and then what we do is this integration is with respect to t. We have taken this out, therefore dt comes out, and f of t also comes out. What we get inside the bracket is s to infinity e to the power minus ft into ds. क्या बात है? See the picture. ds comes inside, dt goes outside. So this integration comes out, this integration enters. Okay. So this can be written as integration from 0 to infinity f of t, and then we integrate this. Integration of e raised to minus ft with respect to s. Try to understand this integral. It's very simple. Integration of e raised to x into dx. What is the formula? Integration of e raised to x remains as it is. Correct? And we have to divide by something. That something is nothing but derivative of x. And derivative of x is a, because x is 1 and a remains. So this is a direct formula for integration. Right? So here we integrate with respect to s, not t. So remember, here we are integrating with respect to x. Therefore, a remains. Here we are integrating with respect to s. So minus t remains. And therefore, this integration is e to the power minus st as it is. No problem with numerator. So we have to think about denominator. Can you write down this value? Integration of e raised to minus st with respect to s. Here I have to write minus t. And then remaining things. dt. Also s to infinity. Because of this definite integrals, lower limit and upper limit remains. So this is equal to 0 to infinity above t into bracket. Upper limit gives 0, lower limit gives 1 by t, and then f of t is there. Okay. Now question is why 0 and why 1 by t? So let us try to understand this. E goes to minus infinity upon minus t, and then lower limit this. So minus minus plus and e raised to minus st, because s is replaced by s, so it remains, and divided by minus t. So minus minus plus we have written, so I don't write this. E raised to minus infinity 0, and therefore you are through. Okay. Here e raised to minus st, I have to write. Yes, it was wrong. Okay, this is correct. So if we simplify this, see the simplification is standard one, e first and remaining thing later. So that is what is the right method of writing. Then what is the bracket? It remains f of t divided by t. And now we can imagine this looks like Laplace transform. But how to identify Laplace transform inside the bracket? So 0 to infinity we have to leave, e we have to leave, dt we have to leave, and what is left is nothing but f of t upon t, which is same as Laplace of 1 by t times f of t. So this is LHS. Remember please, while doing this theorem, mind it very well that you have to start from RHS and not LHS, because it is very difficult in this way. Because if you write this, then you write this, then this, and finally definition of this. This is very difficult to adjust, right? Therefore, we can start with the RHS and reach to LHS safe. Okay. तर हा जो क्वेश्चन होता तो होता सेकंड शिफ्टिंग प्रॉपर्टी. आता सेकंड शिफ्टिंग प्रॉपर्टीवरती काही क्वेश्चन्स विचारलेले असतात, प्रॉब्लेम्स विचारलेले असतात. ते प्रॉब्लेम्स आपण बघून हा व्हिडिओ थांबवूया. ओके, 2 क्वेश्चन्स मी तुम्हाला या पद्धतीचे देणार आहे. ओके, सो if you are asked to find out Laplace transform, if you are asked to find out Laplace transform is the bracket 1 by t times sin t or sin 2t. Suppose this question is there. Now we can observe that just like shifting property, effect of multiplication by t and so on, we can note that there is 1 by t, and that's why we use property. Because of 1 by t, we are using property. f of t is there, and we can see 1 by t. So here we can write solution. Oh. Laplace of 1 by t into f of t is equal to integration from s to infinity and is into ds. This is what is the effect of division by t. So directly comparison using f of t, sin 2t. Very simple question. You know, if f of t is there, in so many videos you have seen that if f of t is ready, take Laplace. Sin 2t. It is denoted by, can you recall? If this is there, take Laplace, and then what to write? Can you guess? Is notation for Laplace, and this 2 upon a square plus 4 remains, because here we can practice Sin 80 Laplace is, can we recall again, a square plus a square. This is standard formula for sine. Therefore, 2 upon a square plus 4 is nothing but Laplace transform of sin 2t. Question is, what is Laplace transform of 1 by t with about t? For that, we see this side. And we put in 1. If we put in 1, we have left hand side as well as right hand side. So I have left over. Now I am writing right hand side. 2 divided by s square plus 4. And of course ds, not dt. So one formula for integration we have to use. This is nothing but tan inverse of s upon 2 limits from s to infinity. This is the formula. Standard formula is integration a divided by, or we say 1 upon x square plus a square. This is formula from 12th science. 1 by 8 tan inverse x by a. This is what is the story. And therefore, this formula is there. 2 is there, therefore, directly we write tan inverse x by 2. Upper limit we have to put infinity, dangerous limit. Tan inverse infinity. Lower limit, it's not dangerous. Okay, find it. Tan inverse s upon 2. But now what happens to infinity? Tan inverse infinity, you can write pi by 2. So this is also standard formula which you have to remember, right? Tan inverse infinity is equal to pi by 2. Tan inverse 0, if you want to use this, it is of course 0. Okay. Tan inverse 1 is pi by 4 because tan 45 degrees and pi by 4 is 1. So this remains, and minus tan inverse s upon 2. But this can be directly written as part inverse is equal to how? So there is one more standard formula. That formula I am telling you, it is in 11th science. Tan inverse theta plus cot inverse theta is, it remains pi by 2. So there are some standard formulae from trigonometry, and therefore this answer is completed. So this was the problem depending upon effect of division by t. To calculate Laplace transform, we find out f of t, Laplace, and then we apply integration. So this is what is the thing. Okay. Now imagine, this question is over as far as this video is concerned. But now I am discussing about one more question. So if I replace this by cos, what happens? It's very interesting to see this. If it is replaced by cos, then what we get is this one. See, immediately you can see this is cos, very fast. Here you can change, okay, because there is formula for cos. Do you remember what is Laplace transform of cos 80? It's s upon s square plus a square. Very good. So here we have write yes, that's all. But this is not the whole story. It is also there, cos. This is replaced by yes. And now formula for integration is going to change. That formula I am telling you, integration of f dash x upon f, or we may say like this, f dash upon f. This directly becomes log f. See magic. If numerator is dash and denominator is f, answer comes log f. So here you can see derivative of denominator is in numerator, but we have to adjust this. Okay, so we can adjust in this way. Integration 1 by 2 twice s divided by s square plus 4. This is called adjustment, and which gives you answer 1 by 2 times log into bracket s square plus 4, right? And this bracket complete, limits from s to infinity, right? So this is what is the thing. And now question comes. That's why this question is taken. Suppose you have put infinity, half times log into bracket infinity. No, then s, there is no change. Because you are putting s equal to s, right? But this log infinity matters, and this comes infinity. See this. Okay, this is exceptional case. In this case, we say that Laplace transform doesn't exist. ऐसा भी हो सकता है, we cannot find Laplace transform of this 1 by t cos of say 2t. Thank you.